Welcome to our comprehensive guide on building flow services in WebMethods. In this video, we'll explore what flow services are, how they work, and why they're essential for orchestrating business processes. Flow services allow you to encapsulate a sequence of operations, manage data flow, and automate tasks efficiently. Whether you're new to WebMethods or looking to deepen your understanding, this series will walk you through every step, from basic concepts to advanced techniques. Let's begin by understanding the core idea behind flow services and their role in integration projects. Flow service is written in the WebMethods flow language, enabling you to encapsulate multiple services within a single, manageable unit. This approach streamlines complex business logic, allowing you to control the flow of data and execution. For example, a flow service can process a purchase order by logging it, performing a credit check, and posting it to an ordering system. The power of flow services lies in their ability to invoke other services, including built-in and custom ones, and manage their interactions seamlessly. Let's see how this encapsulation benefits real-world business scenarios. Flow services are created and maintained in Designer, WebMethods graphical development environment. Designer saves flow services as XML files, ensuring compatibility and easy management. It's important to note that flow services cannot be edited with a text editor. All modifications must be done within Designer. This ensures that the structure and properties of each flow service remain consistent and reliable. Designer provides tools for visualizing, editing, and debugging flow services, making development intuitive and efficient. Flow services are composed of flow steps, which are the basic units of work in the WebMethods flow language. Each step performs a specific function, such as invoking another service, editing data, or controlling execution. The integration server interprets and executes these steps at runtime, ensuring that your business logic runs smoothly. Flow steps can be grouped, repeated, or branched, allowing for flexible and powerful process automation. Let's dive deeper into the types of flow steps available and how they shape your flow service. Control steps are essential for directing the execution of a flow service. They allow you to conditionally execute sequences, retry operations, loop through arrays, and branch to different steps based on data values. For example, you can use a loop step to process each item in an array, or a branch step to select actions based on a variable's value. These control steps provide the flexibility needed to handle complex business scenarios, ensuring that your flow service responds dynamically to varying conditions. Invocation steps are used to execute other services within your flow. The invoke step is the primary mechanism for calling services, whether they're custom-built, built-in, or provided by adapters. This allows you to integrate various functionalities and external systems into your flow service. By chaining invocation steps, you can build complex workflows that automate business processes and ensure data consistency across systems. Let's explore how invocation steps are configured and used in practice. Data handling steps such as map allow you to manipulate the pipeline, the data structure that holds input and output values for your flow service. With map steps, you can map variables, add new fields, or drop unnecessary data. This ensures that each service receives the correct input and produces the desired output. Data handling steps are crucial for preparing and cleaning up data as it moves through your flow, supporting robust and error-free execution. Branch step enables conditional execution within your flow service. By evaluating the value of a variable or an expression, the branch step determines which child step to execute. This is particularly useful for handling different business scenarios, such as processing orders based on payment type. You can branch on switch values or expressions, and even specify default actions for unmatched cases. The branch step adds decision-making capabilities to your flow, making it adaptable and intelligent. Loop step is designed to repeat a set of flow steps for each element in a specified array. This is ideal for processing lists, such as line items in a purchase order. By specifying an input array, the loop step ensures that each item is handled individually, allowing for detailed processing and aggregation. Nested loop steps can be used for multi-level data structures, providing powerful iteration capabilities within your flow service. Repeat step allows you to retry a set of flow steps based on success or failure conditions. This is useful for handling transient errors, such as network issues or busy servers. You can specify the maximum number of retries and the interval between attempts. The repeat step ensures that your flow service is resilient, automatically re-executing steps when necessary and minimizing disruptions in business processes. Sequence step groups a set of flow steps into series, ensuring they execute in order. While most flow services treat steps as an implicit sequence, explicit sequence steps are useful for grouping alternative beneath a branch or specifying exit conditions. You can configure sequence steps to exit on failure, success, or completion, providing granular control over process flow and error handling. Exit step provides a mechanism to exit from a flow service or a specific flow step. You can configure it to exit from the nearest loop, repeat, parent, or the entire flow. Additionally, you can signal success or failure, throwing exceptions when needed. This step is crucial for managing control flow, handling errors, and ensuring that processes terminate gracefully or with appropriate error messages. Pipeline is the backbone of data management and flow services. It holds input and output values, allowing services to share and manipulate data as the flow executes. Each step in the flow accesses the pipeline, ensuring seamless data transfer and transformation. Understanding how to map and manage pipeline variables is key to building robust and efficient flow services. Designer offers two views for building flow services, the Tree tab and the Layout tab. The Tree tab lists steps sequentially, providing a condensed view, while the Layout tab displays steps as a flow chart, showing execution order visually. Both tabs offer the same capabilities, so you can choose the one that suits your workflow best. Switching between tabs is easy, allowing you to leverage both perspectives during development. You can create a new flow service by starting with an empty template or generating one from a source file, such as an XML schema, DTD, or XML document. Designer guides you through nomming, folder selection, and template initialization. This flexibility allows you to build custom logic or automate data extraction from structured documents, streamlining integration and process automation. Creating a flow service from an XML document, Designer uses the reference DTD or XML schema to generate elements and logic. This approach is ideal for services that process XML data, automatically mapping document structure to flow steps. You can specify the source location, whether it's a URL or local file, and Designer handles the rest, generating document types and schemas for seamless integration. Creating a flow service from a DTD involves specifying the DTD file and selecting the root element. Designer generates document types based on element references, handling multiple and single references appropriately. This process ensures that your flow service accurately reflects the structure and constraints defined in the DTD, supporting robust XML data processing. Building a flow service from an XML schema, Designer generates its document types and schemas, supporting strict, lax, or no content model compliance. You can configure document type handling, namespace prefixes, and validation options. This method is powerful for integrating complex XML data structures, ensuring that your flow service aligns with external schema definitions and business requirements. Designer manages caching of elements when generating flow services from large XML schemas. Increasing cache size can improve performance by reducing network traffic and speeding up service creation. Proper cache configuration ensures that all generated document types are readily available, supporting efficient development and deployment of complex flow services. In creating flow services from XML schema, you can assign custom namespace prefixes to elements. This ensures unique and valid nomming, supporting interoperability and clarity in document types. Designer allows you to change prefixes as needed, maintaining consistency with external systems and schema definitions. Flow steps are inserted using the Flow Service Editor toolbar or the palette view in Designer. You can drag and drop steps, arrange their order, and build complex logic visually. This intuitive interface streamlines development, allowing you to focus on business logic rather than technical details. Proper step arrangement ensures that your flow service executes as intended, supporting reliable automation. You can move flow steps up or down in the editor to change their execution order. This flexibility allows you to refine your process logic, ensuring that steps run in the correct sequence. Toolbar buttons and drag-and-drop functionality make rearranging steps quick and easy, supporting iterative development and optimization. Some flow steps, like loop and branch, have child steps that are indented beneath them. This hierarchy defines which steps are executed as part of a parent step, supporting nested logic in complex workflows. Promoting or demoting steps within the hierarchy is easy, allowing you to structure your flow service for maximum clarity and efficiency. Each flow step has unique properties such as comments and labels, which are managed in the Properties view. Labels allow you to reference steps in other flow steps, control behavior, and enhance readability. Proper property configuration ensures that your flow service is well documented, maintainable, and easy to debug. Invoke step is used to call other services within your flow. You specify the service property, timeout, and input-output validation options. Linking pipeline variables to service inputs and outputs ensures seamless data flow. The invoke step is central to integrating functionalities and building modular, reusable processes. WebMethods provides a library of built-in services for data transformation, mathematical operations, XML processing, and database access. These services reside in the WM public package and can be invoked from your flow service. Adapters add more built-in services, expanding integration capabilities. Leveraging built-in services accelerates development and ensures reliability. You can invoke services on remote integration servers using the pub-remote invoke built-in service. This requires configuring an alias for the remote server and specifying the fully qualified service name. Remote invocation supports distributed architectures, enabling seamless integration across multiple servers and environments. Branching on a switch value involves using a pipeline variable to determine which child step executes. Each target step has a label that matches possible values of the switch variable. This approach is ideal when you know the exact values to branch on, such as payment types or order statuses. Proper label assignment ensures accurate conditional execution. Branching on expressions allows for more complex conditions, evaluating multiple variables or ranges. Each child step has an expression label, and the first one that evaluates to true is executed. This method is powerful for dynamic decision-making, supporting scenarios where conditions are not limited to fixed values. Branch steps can match null or empty values by setting the label property to null or leaving it blank. This ensures that your flow service handles cases where variables are missing or empty, preventing errors and supporting robust logic. Proper handling of null and empty values is essential for reliable process automation. To handle unmatched cases in a branch step, use the default label. This ensures that your flow service always has a fallback action, preventing execution from falling through and supporting comprehensive error handling. Only one default step is allowed and designer evaluates it last. When a branch step needs to execute multiple steps conditionally, use a sequence step as the target. Grouping steps beneath a sequence allows for complex alternatives, such as processing orders differently based on payment type. Sequence targets can contain any valid flow step, including nested branch steps. Build a branch step, insert it into your flow service, configure properties such as comments, scope, timeout label, switch, and evaluate label. Add child steps, assign labels, and ensure that conditions are mutually exclusive. Proper configuration ensures that your flow service executes the correct logic based on runtime data. Repeat step can be configured to retry child steps when any step fails. Set the repeat on property to failure and specify the count and interval. This is useful for handling transient errors, ensuring that your flow service is resilient and can recover from temporary issues without manual intervention. Alternatively, the repeat step can repeat child steps until a failure occurs by setting repeat on to success. This is useful for looping processes that should continue as long as all steps succeed. Proper configuration ensures that your flow service handles iterative tasks efficiently and stops when necessary. Sequence steps can be configured to exit on failure, success, or completion. Exiting on failure skips remaining steps if one fails, while exiting on success stops after the first successful step. Exiting on done executes all steps regardless of outcome. These options provide granular control over process flow and error handling. Loop step operates on an input array, executing its body for each element. You can specify an output array to collect results from each iteration. Understanding dimensionality changes within the loop is crucial for proper data mapping and aggregation. This supports detailed processing of lists and arrays in your flow service. Build a loop step, insert it into your flow service, specify input and output arrays, and build the loop body by adding child steps. Proper linking of pipeline variables ensures that each iteration processes individual elements correctly. Debugging and validation in Designer help ensure reliable execution. The exit step can be configured to exit from the nearest loop, repeat, parent, or the entire flow. You can signal success or failure and provide custom error messages. Proper use of exit steps ensures that your flow service handles errors gracefully and terminates processes as needed. Map step is used to adjust pipeline contents, link variables, add or drop fields, and initialize values. It's especially useful for preparing data for subsequent steps or cleaning up after processing. Map steps support document transformation and hard-coded value assignment, enhancing flexibility and data integrity. Designer allows you to print flow services by viewing them as HTML. This feature displays all aspects of the flow, including parameters, steps, and pipeline behavior. Printed documentation supports review, sharing, and compliance, making it easier to communicate process logic with stakeholders. Compare tool in Designer enables you to compare two flow services, either on the same server or across different servers. This is useful for version control, auditing, and ensuring consistency in process logic. Comparing flow services helps identify differences, track changes, and maintain high-quality integration solutions. Debugging and validation are essential for ensuring that your flow services execute correctly. Designer provides tools for testing, mapping data, and validating input-output against service signatures. Proper debugging helps identify issues early, supporting reliable and efficient process automation. Adopting best practices in building flow services ensures maintainability, scalability, and reliability. Use descriptive comments, organize steps logically, handle errors gracefully, and validate data thoroughly. Regularly review and optimize your flow services to align with evolving business needs and integration requirements. We've covered the essentials of building flow services in WebMethods, from basic concepts to advanced step configuration. Understanding flow steps, pipeline management, and control mechanisms empowers you to automate and optimize business processes. Continue exploring Designer's features, experiment with different step types, and apply these techniques to your integration projects for maximum impact.